Crash helmet design, prototyping, and testing, the prototype phase. So we're finally at the phase where we're going to be making something. And we're going to be making some of those ideas that we generated during the ideate phase. Specifically though, we're going to be drilling down to the helmet-related ideas. In any prototype phase, what we're looking to do is create some sort of a mock-up that we can test out very quickly with the end user to see how it works. We can create simple physical devices, we can create storyboards, we can use paper, we can use 3D printers to create a very simple model. But the idea is to really keep it simple, make your prototype very fast, and if you're going to make a mistake and you're going to fail, fail quickly. Don't invest a lot of resources or time or manpower into creating this amazing finished product only to find out that when you hand it over to the client, it was completely in the wrong direction, utterly unusable, not user-friendly, and really not at all what they had in mind. We want to create some very simple mock-ups so that they can test them out. Let's see how they work. We're working on a limited time frame, so we're really going to hone in on designing, prototyping, 3D printing a helmet. However, that helmet is going to look very different depending on which team we're looking at. All the different teams are going to be designing something different. You're going to be incorporating different elements in order to generate drag, in order to create your cushioning. So we're prototyping, but we will have a collection that really represents quite a wide variety of different ideas. So we've moved back and forth between focusing and flaring. Now we're moving back towards focusing during this prototype phase because we're drilling down to simply making some form of a helmet. That will be our protective device for the egghead, although our helmets will all look quite different as we produce our own concepts for this prototype. So how will we do this? Well, we need to make two different pieces in order to create this egg crash helmet. One is the hard shell, two is the cushioning component as well as the drag. The drag could be incorporated into the hard shell, could also be incorporated into elements that we add on in addition to the shell. So let's think about these two different parts. I will be providing you a tutorial right now in Tinkercad on how to design and print that 3D hard shell. You'll print it out on the 3D printers and then you'll add the additional elements. If you know how to work in a different program, for instance Fusion 360, please feel free to use that. If you've never designed and printed in 3D before, then go forward with me on the Tinkercad portion of this. Then you'll need to think about adding in these additional pieces once you've gotten your 3D print off the printers. You'll want something like, I don't know, bubble wrap or foam mounting squares or this kind of egg crate cushioning or even, this is a great little video I found on YouTube, sponge and or silicone gel. All these are quite squishy. So these will be able to provide that additional cushioning that you want between the egg and the hard shell so that you can increase delta T and thereby decrease F during impulse as the crash occurs. You may also want to add some additional drag by adding something like a parachute. You certainly don't have to do that. You could add some of these little fins so that you increase drag and reduce the smoothness at which the helmet is moving through the air as it falls to the ground. That's up to you, but drag, remember, is an important thing that we do want to try to incorporate in our design. You'll also need something like a rubber band or string, some way to create a chin strap so that you are holding the egg in the helmet. And as you move along, you're going to be working back and forth with these ideas, working with your teammates and deciding on how is this shell going to look and how are we going to add in these cushioning components and drag components as well. And don't forget, some sort of an attachment to attach that egg. You're going to be doing this quickly though. You do not have several class periods. You've only got a couple in order to create a start to finish prototype. Remember, we are not spending lots of money and time and resources and manpower on our prototypes. We move through quickly, we see how they work, and if they are functional and effective, we can continue to iterate on that design or we can move on and test out something else. Ultimately, the prototype phase is about making simple mock-ups, iterating quickly, and if we're going to fail, failing fast. So go to tinkercad.com so that we can get started with our 3D design. If you already have a Tinkercad login, go ahead and use it. If not, you'll need to create one and you can use your Google login in order to do so. I'm going to show you real quickly a design I created a little earlier, and then we'll actually start a design and move from start to finish so that you can get a sense of how to use Tinkercad if you've never used it before. If you've used it, please skip this section and move right into designing. So I've created this little design previously. Once you have created a design, you can examine it in 3D, and you'll notice that in this design I've got basically a shell with a cutout for the visor so that the egg can see out, and I've got some little drag features that I've added as well, and that this shell has a hollow space for the egg head to fit. Okay, so I can tinker this, or I can start new, and I'm going to go ahead and start new with create a new design so that you can get an idea of how to do this start to finish. Now, you've got a couple choices when you first get started. You can select something that is kind of a hemisphere shape or a paraboloid shape. I'm going to go with a paraboloid shape, but I'm going to show you a couple of other additional options. These are sort of your two starter options, though, especially if you've never used Tinkercad before. Now, you see that you've got a grid. The grid is being measured in millimeters. If it's not, for some reason, if you've previously set it to inches, set it to millimeters. And leave the dimensions of the grid as is, but change the snapping to a very, very tiny snap down to 1/10 of a millimeter, 0.1 millimeters. You'll notice that you can move the grid to all these different orientations: top, front, bottom, left side, right side, etc. And if you ever lose your orientation, you can hit the home key and you can zoom in and zoom out. So let's get started. I'll just place a paraboloid right here on the platform. I'll zoom in a little bit, and I'll rotate so that you can see that it's sitting right on top of the platform. Now you'll notice that I have a little arrow right here. If I lift up, it raises it above the platform, and you can even see how many millimeters up above the platform it is. I can lower it, and once I hit 0, it's on the platform. If I go negative, it's below the platform. So you really need to keep this at 0. And then you can rotate back, zoom in a little more. And if you touch one of the sizing dots, you can see the dimensions. So this is 20 by 20. You can also just simply count the number of squares, because each one of these large grid areas is 10 millimeters by 10 millimeters. We know, though, that the median egg size is something more along the lines of, what did we say, 44 millimeters across. So the diameter is 44. So we are really going to have to make this quite a bit larger. I can pull this out, pull it out, more. I'm going to need to keep sizing out. All right. Let's get larger. If I get up to, there's around 44 or so right now. Okay, a little further in this direction. Now the problem is, though, if I go with just straight up 44, that's exactly the median size. So I really am going to have to get a little bit larger in each direction. So if I go up to something like, I don't know, 48, 49, it's really your call. You're going to need to make some decisions about that in each direction. Okay, 50 is probably a little much, but that's really your call. You're going to have to decide that based on how much width you want for the width of the shell and how much cushioning you want to add. Now, once I've got that size, I also need to think about the height. If I touch this top dot, I can see that the height of this paraboloid is about 20 millimeters. If you recall, the height for a median egg was around 55, so we really need to hit 27 or 28 in order to cover the entire top half of the egg. Now you don't have to do that, but that's your call. Again, how much do you want to cover? So I'm going to hit about 28. That looks good. Okay, I can see it. So far so good. Now I'm going to look at the underside. Okay, now you'll notice on the underside, this is a solid object. I don't want a solid object. I need to have this as a shell. So here's what I'm going to do. I'm sort of reset my orientation. I'm actually going to just put a box around this and slide it over to the side. I'm literally just dragging my mouse. Okay. If you want to move your object around the screen, if you select it, you can use the arrow keys. I'm pressing the up arrow key and it's very slowly moving up the screen. Pressing the down arrow key, slowly moving down the screen. Left arrow key, moving to the left. Right arrow key, moving to the right. That's what your arrow keys do in terms of sliding you around the screen. Then again, you can zoom out, zoom in, using the plus and minus keys over on the left, and then you can move around your object using the box. So I need to make this a hollow shell. So what I'm going to do is take this object, and I'm going to Command C to copy it, and then Command V to paste it. So you'll see I've got a second one. Okay? Now I need to make it a little bit smaller, because if I'm going to make a hollow inside, the inside shell needs to be a little bit smaller. So I'm just going to hold down my Shift key so that I can make this a bit smaller and keep all of the scaling to be the same proportions. So essentially these are similar objects in terms of geometry. They're not congruent, they're similar because they're the same proportions, but they are not the exact same size. Okay? So once I've done that, again, holding down the Shift key, shrinking that down a little bit, what I want to do is change this object into a hole. So I'm going to click that hole button. And the only thing is it's a little bit difficult to see the difference between the two of these since this is kind of gray. So I'm going to go back to my original object. Again, you can see that it's a gray color, but let me change it to something more like a blue. Okay, that way I can really differentiate these colors. Now I'm going to go back to this hole. And by hole, I'm saying H-O-L-E, not W-H-O-L-E, H-O-L-E. It's literally a hole. And I'm going to push it into the other object. Now, if I rotate to the bottom, you can see that I stuck it in there. It's not perfectly aligned, so I'm going to just use the arrow keys. I'm pressing the down arrow key, and I'm pressing the left arrow key, and I want to get that so that it's just nicely aligned. There we go. Okay? I'll rotate back. And I will just put a little box around these two objects and then go up to the top where it says group and group the two. Now you didn't see much change from the top, but if you look at the bottom, now you can see that I've made a shell. Be absolutely certain when you are at this stage that you create your shell of a thickness that will protect the egg, but that you also provide plenty of room inside for the padding. You may need to extend your outside dimensions so that once you build in the thickness of the shell, there's still plenty of room inside to add as many millimeters of padding as you want in order to give that egg some cushioning. Now the next thing I need to do is think about the fact that I need a little visor right here. So you can use anything you want. Let me see, how about if I use a round roof. Okay, take that, move it in. Remember, it's ultimately going to be a hole. Let me just push that in right there. I want to stretch this out a little bit. Stretch that out. Push that in. Change it into a hole by clicking this button. And now I can select all, go make a little box around it, group all of that, and now I can see how I did. Oh, that's pretty good. All right, so now the egg can see out. That's his little visor. Now what if I want to put some little drag features around the side? There are a ton of shapes over here on the right. Right now we're working in the basic shapes. If you go into the shape generators and look at all, there are a lot of other neat shapes in here. Okay, now let's think a little bit about how we can put some sort of drag elements on this helmet right here. Let's go back to our basic shapes. And let's find the scribble. This is a really cool feature. So I'll just pop it right onto the screen, but then it's going to allow me to make a scribble. So what if I do something like make a little curve that matches the curve of the helmet, and then I put in some little fins. These are almost like flaps that will help catch the air and introduce some drag resistance from the air resistance on my helmet. So once I've got that created, I just select Done. And again, I can zoom out. and I can add this onto my helmet. Now, there's a few different ways that I can add this on. I can just grab it, stick it on the side, and say, well, okay, that looks good, I'm done with it. But you'll notice that that doesn't really fit really well just yet. So I may need to use some of these additional tools in order to make some adjustments. So let's think about how we might want to do this. You'll see that there are some curved arrows, and that those curved arrows will allow me to rotate in the different planes. There's 3 sets. So this one allows for rotation this direction, this one front and back, and this one side to side. So let me use this one front to back, and you'll notice there's sort of 2 different sets of adjustments. If I stay on the inside, it's in very strict increments, 22.5 degrees and 45 degrees. But if I use my cursor and move up to that outside band of numbers, they're much finer adjustments. So it's just going to take you some little getting used to this. So that looks a little bit better, and you're going to constantly be moving around like this around your helmet in order to adjust. So that really needs to be lifted up, and I can see that I'll need to rotate this some more. Okay, that's pretty good. I may need to move it into the helmet just using my arrow keys. Let's look around. Now I notice that there's a little bit of a gap there, so I need to keep moving that in, because the last thing I want is for there to be any gaps. Rotate this around a little bit more. Okay. Now at this point you also need to consider the angle at which you're attaching any kind of a drag element. I'm showing you 2 different ways of attaching a drag element. My initial demonstration piece with the helmet that I had previously created, the one I'm showing you now. One design may be somewhat better than the other in terms of capturing air resistance. So think about that. It may not necessarily be what I'm showing you right now in this picture. And again, you may not want to have any kind of drag element at all. That's entirely up to you. And once I have it kind of the way I like, you can also look on the inside, make sure it doesn't go all the way through because you don't want it to interfere with the fit of the helmet. So that's pretty good. And then what I can do is I can actually just Command C and Command V to make a second copy. Move this guy over. I'll need to rotate it back the other direction. Use the arrow keys. Grab it and move it. Use those arrows for some fine adjustments, and that looks pretty good. Make sure that's in there and make sure that it's not going all the way through. Okay. Look all around. All right. So you can do whatever you want to in order to add some additional drag onto the helmet. Just make sure that it's mounted and attached very, very tightly with the helmet. You don't want any gaps. You also don't want giant things hanging off to the side, because if you make it too far extending away from the helmet, supports are going to need to be used in order to print on the 3D printer. That's not the end of the world, but it will sort of make the print a little bit more challenging to accomplish. You may also want to think about adding a couple of holes. Remember, you can use something like a cylinder and size it really small and ensure that it is a hole, and then rotate that and stick it in the side here in case you want to make the attachment for the chin strap and or an attachment for a parachute. You're certainly going to need some way of attaching a chin strap, and if you don't have that, you're going to be stuck just trying to tape it on or glue it on, and that will not hold. So you are going to need to use some sort of a hole on each side in order to make that attachment point for the chin strap. Okay, now once you're all done, again, sort of refocus. Make a big square around everything. Select Group. The color of the objects on screen, not really relevant because you're going to use whatever filament is in the 3D printer to do the print. Make sure everything's sized just the way you want it. It is. You need to change the name. So this would be something like Egg Crash Helmet. Okay. And at this point, you're ready to export. So you press the Export button. We want everything in the design, and we're going to output as a .stl. That .stl will be downloaded to our computer. It'll go into our Downloads folder. You see that? Egg Crash Helmet.stl. And now we have our file that is a 3D print file, a 3D design, and I need to go to the next step, which is opening up FlashPrint. FlashPrint is my program for actually taking that 3D design to the FlashForge printers. I have to prepare that design by slicing it, literally identifying layer by layer how the printer should print it. So I will load up that particular design. You'll find it in your downloads folder. There it is. It's nicely on the platform. I will select print. Make sure that it says FlashForge Finder. If it doesn't, you'll need to go to your machine type under print and change it. So once you're ready to print, you'll make sure that it's printing in PLA. You can disable the supports unless you have a lot of things sticking out to the side, in which case you'll need to enable them. The raft, you probably don't need to enable the raft because you probably have sufficient surface area at the base, but if you're concerned about that, you can enable a raft. That means a little platform that goes underneath. You really don't need hyper as far as the resolution. You don't want low, that's a little too low. Anywhere from standard to high is fine. I typically use high. And under more options, there's some additional information that you can fill in here, including shells, infill. Infill means how much filament is going in between. Typical is 15%, but if you want a sturdier shell, you could use something like 20 or 25. The hexagonal pattern, that's standard. Speed, this works fairly well. Temperature, we often raise the temperature to something like 225. We found that works a little bit better on our printers. And at this point, you can just save the configuration and say, OK. What you want to do now is ensure that this slicing file goes onto a flash drive. So instead of it going into your downloads folder, you will put a flash drive, USB drive, into your computer and then save it onto that flash drive. Right now I don't have one in my computer, but you'll need to put it onto the flash drive. And you can save it as a .gx. Both of these will work, but I typically use .gx. And then say save. Right now I'll just throw it onto my downloads folder. What you'll see is you'll see the file prepared for printing. It will tell you how long the print will take and how much filament will be used. At that point, you will take that particular flash drive that you just saved your file onto over to one of the FlashForge Finder printers. You'll put it in, you'll transfer that file to the printer, and you'll start your print. Once you've created your design for the helmet in Tinkercad or another design program, make sure that you also document that design, meaning that you need to show an engineering drawing for all of the different views of that particular product. So we need to see a perspective view, that's a three-dimensional view, as well as a front, side, and top view. I'd like to also include a bottom view. That's not always standard in engineering drawings, but I think it's helpful in this particular case since this interior is hollow for the helmet, and I think it will really help clarify what the design looks like. So what you'll need to do for each of these is simply do a Command-Shift-4 in Tinkercad and capture that three-dimensional perspective as well as the orthogonal view. So you can hit that box and touch each of the sides, front, side, top, and bottom to get those views and do those screen captures. You can then crop them and assemble everything into a very simple slide in a Google slide, and then output that as a PDF. Make sure also, though, that for at least a couple of your views, preferably the top and bottom view, that you hit the sizing dot so that the dimensions will display on screen. When you do that, you only have a couple of seconds in order to be able to conduct the screen capture, but I think it's important that you show those dimensions so that the overall views of the helmet as well as the size of the helmet are displayed. Very, very important. All right, we are nearing the end of the prototype phase. Remember, prototyping is about making simple mock-ups, iterating quickly, and if you're going to fail, failing fast. So we've got our 3D designs in Tinkercad or Fusion 360. You've documented those with an engineering design diagram showing the different views. You've gotten your helmet printed out on the 3D printers and you've added any additional padding or drag components that you wanted to add in. So now you want to make sure that you can get eggs that are of the median size and that are slightly larger and slightly smaller to ensure that they fit within that helmet. Can you get them in, and can the egg see out? Remember, that's important that we not diminish their sensory or their mobility capabilities. Can you ensure that the strap, whether it's a rubber band or a string, fits appropriately and holds the egg inside its helmet? Can you make sure that you can get the egg in and out of that helmet in the time span that you designated in your problem statement, whether that was 5 seconds or 10 seconds? So you need to make sure that everything is sized appropriately, test that fit, photograph your egg in his helmet, and then from there, we'll be ready to move on to the final phase of the design thinking process, testing.